There's just something so peaceful about longboarding. Something that just can't be replicated by sitting in a bike or car. Kinda reminds me of a nice POW day on skis where you can just glide along and feel weightless. Unfortunately, this zen-like state comes to a screeching halt once you encounter a hill. Going uphill may be a slow, grueling task and not a whole lot of fun, but I find downhills to be where the real problem begins, because downhills are where you have to brake. I'm still a scrub at longboarding, I'll admit it now. I bought this longboard maybe half a year ago for $40 used, and thus I lack the experience to do the crazy sideways sliding stop, so I generally brake just by putting my front foot parallel to the board and then sliding my rear foot along the ground as shown in the video. I find this process to be unnecessarily sketchy and awkward, and I just hate how it ruins your shoes grinding it against all that asphalt and concrete. And so I looked to create a solution for this. A quick Google search led me to 3 separate solutions to this braking problem. The first and most impressive solution is from Breakboard, which is a set of brakes designed for longboard skateboards, exactly what I was looking for. And these come in the form of specialized rear and front trucks with the braking system part of the rear truck assembly. This brake is activated by a pedal on top and activates 2 clutches which are attached to the rear wheels, and these will slow those rear wheels down. Fantastic looking engineering, beautiful product, love how it's all color coded, and just love how it's all nicely machined. Imagine that's aluminum, just looks beautiful. Imagine it works super well. Just unfortunately at $200 US, about $270 Canadian, which is over 5 times what I spent on my complete longboard. And seeing as this Kickstarter was last updated, was that 2014, so 8 years ago, I don't think this is really something I could go ahead and buy, and it just was way too expensive for what I needed. The second idea is done by Slide Brake Vector, where you can actually find these guys on Amazon if you want to buy these brakes, and is basically a little pedal that is on the bottom of the longboard with a screw that sticks up through the top. You press on to that screw, it presses down on this, and this rubs on the ground. Super simple solution. I think these were going for about $80 on Amazon, so a little more reasonable price, still a little more than I was hoping to spend, but definitely a decent solution that is something I could have bought right then and there. Unfortunately, I don't like the idea of having this underneath the longboard, as it just reduces the clearance a ton. I do the vast majority of my longboarding on and off of sidewalks, and so going from the road onto the sidewalk, I can just see this catching all the time and bringing me to a dead stop, so it just wasn't going to work for me. The second idea is basically same pedal on top, but this time it has 2 little arms that stick out to the side, and those arms just wear directly on top of the wheel. And this was done first, or I don't know if it was first, but this was done by Frog Stop, which they're out of stock and I couldn't see anywhere else I could buy them. And also just this little video done by Legal Longboards back in 2014. I guess there was a big longboarding craze back then, which I think I can remember, and everything seems to be 2014 longboard related. But really blurry video. But as you can see, same idea, has a little pedal that presses on the wheels. Super simple, this looks super cheap to make. I don't like how the actual bearing that presses on top of the wheel, how it's right in front of the wheel, because I can see that getting pressed up against when you turn, because the wheel will slide back and forth. And there's some comments saying just to add a spring so to raise this up so these aren't touching the wheels, which I think is a great idea. It's what I ended up adding to my longboard brake, but I'll talk about that in a bit. And so This is actually kind of the idea I went with. I thought it was a simplest solution, just a little pedal you press on and then 2 pads that'll press on either of the wheels. And so I got to designing, and as I was designing I had the thought, hey, why do we have to put the brake on the back foot? Why can't we put the brake on the front foot? Let's do a quick little stick figure drawing to show you kind of why I thought that way. And so you got your longboard here on the bottom, arrows pointing that way, that's the way you're going. So you got your front foot and you got your back foot. The main problem I saw with your back foot is that it's constantly going on and off the board as you step off to push, put it back on to glide. Step off to push, put it back on to glide. And you're just constantly moving it. While your front foot is stationary, it's just sitting there. You might rotate it side to side and as you adjust from pushing off and gliding, but it's not going very far, it's just rotating in spot. And also, as you have eyes on the front of your head, you don't have eyes on the back of your head, you can see your front foot, or your back foot, you're blind to it. You don't know where it is besides where you feel it is. And so if you have a brake on your front foot, you can see where the brake is, and your foot doesn't need to move very far, so it's easy to not accidentally step on the brake and face plant because your board suddenly went to a dead stop. But to explain why this is a bad idea, we'll have to go into a bit of control theory from engineering. One of the basics of control theory is the idea of a feedback loop. Feedback loop is a fairly simple concept, and I'm going to draw a very basic version of it. Usually there's a bunch more inputs and outputs and craziness to it, but I'm going to make it very simple just for this example. So a feedback loop, you'll have your input, you'll have an addition or a subtraction section. Talk about that more in a second. You go from that addition to subtraction, you have whatever your system is, so that's whatever adjusts your symbol or signal and creates your output. And then from that output, you'll have a bit of a feedback loop, which is usually done by sensors that sense the output, bring it back to the input, and then that re-adds into your system. With a positive feedback loop, this will be a positive addition here, and with a negative feedback loop, it is, as you guessed it, negative. Generally, you want to aim for a negative feedback loop, as these don't go crazy. You won't have crazy exponential values, as like with a positive feedback loop where you put a 1 in, maybe you get a 1 back out, it goes back in, now you have a 2 going into your function. Maybe you have a 2 going out, bring that back in, now you have a 3 going into your function, and that'll build and build and build. That's why you get those super high-pitched sounds if you bring a microphone too close to a speaker. It's a positive feedback loop where it just builds up on top of itself and goes to an unstable state. And so you want to aim for a negative feedback loop. And so let's go back to the drawing of the dude on the longboard. Again, beautiful drawing by yours truly. I am a paint aficionado, but we can discuss that more in the future. And so you got your longboard here, you got your person, same, going to the left with your front foot and your back foot. Let's say you got your foot, the brake on your back foot here. You press it down, the board slows down, and your weight moves forward. This reduces the pressure on your back foot, and your board could speed back up again. So you have a negative feedback loop. It doesn't go to crazy values, it just settles and doesn't go to exponentially. Let's say instead you put your brake on your front foot, as I was kind of hoping to do. Press on the brake. Your board slows down, your body shifts forward. Just like if you've ever been standing in a moving bus, the bus driver brakes, you shift your weight to your front foot. Bus driver accelerates, you shift your weight to your back foot to kind of offset your inertia. So let's say again, you're braking with your front foot. You brake, board slows down, body shifts forward. Now you have more pressure on your front foot, so you brake even harder, board slows down even harder, you go forward even harder. Now you got a positive feedback loop. You're just going to build and build and build, you're going to slow it down faster and faster and faster, and sure, you could control it if you're very careful about your foot placement, but if you were uncareful, you just kind of stamped on it or very aggressively braked, very easy that you would go to infinity, you'd have your feedback loop, and you just fly off the board because your board goes to a dead stop while you don't have the time to slow your inertia. So, in case you're wondering, I guess that's why all of those brakes that we saw, they all acted on the back end of the board instead of the front end of the board to avoid that. Which I guess should have been kind of obvious, because the same idea with brakes on your bike. You don't slam on your front brakes unless you're maybe going uphill, because if you slam on your front brakes, your front tire stops and you want to flip over the handlebars, which, not fun. And so with the location of the brake figured out, I decided I'd head outside to get some real world data on where I want to place the brake pedal. To do this, I clamped my GoPro to the back of my longboard using a GoPro clamp mount and stuck some duct tape across it to get an idea of distances so I can look at it and kind of figure out where on the board it was. Unfortunately, doing so introduced me to the villain of this story, the oh so bumpy sidewalk. And as you can see in the video there, the GoPro mount did not win this battle. The sidewalk was made out of repeating squares, and hitting those lines over and over again slowly shook the GoPro farther and farther down until it eventually just completely fell off the board. And so I picked it back up, tightened the crap out of all the screws on it to make sure it wouldn't move anymore, and actually got some usable footage. As you can see here, filming everything nicely. It does slide down a little bit, so it's not YouTube worthy footage, even though this isn't a YouTube video. It's not footage you'd want to just watch for the longboarding, but it was useful. I could actually see that my feet weren't actually stepping too often on those black lines, and if they did, it was only on those front two lines where the back two were still far enough away that I wouldn't accidentally step on the brake pedal. Unfortunately, the sidewalk won this battle too, and eventually the GoPro slid back down and was useless. Not wanting to be a quitter, I decided I'd retighten it one last time and ride it back to my apartment. And this time, the mount stayed on. It didn't fly off again. Unfortunately, the entire mount broke instead of just falling off, which would have been preferable. This GoPro mount and I had been through a lot together, so I was honestly kind of sad to see it go. It had been with me for many years of skiing. One of the prongs on the back of it broke off many years ago, and I just kept it on with one prong and the little white rubber piece that kept it snug, and somehow it survived through many crashes, many successes, and all it took was a couple minutes of riding on the sidewalk, and now it's broken completely. Interesting enough, as you can see in the picture there, it broke through fatigue, which is expected going over those repeated bumps. It was just the back and forth weight of the GoPro stressed the plastic, made a little crack there. Then you can see each of those ridges where broke a little bit more, broke a little bit more, broke a little bit more, until eventually just completely sheared off. With that disaster of an adventure out of the way, it was time to create the SolidWorks model. So here is the finished model that I created for the project. You got the big pedal on top to step on. You got the two supports on either side that hold it to the board. You got the wooden dowel I used as an axle, as well as the two brake pad holders on either side. I decided to go with a replaceable rubber pad into these. So instead of wearing away the 3D printed plastic, I just used that same gym floor matting rubber material that I used for the GPU support, the same kind of grippy substance. Stuck it in here, ended up using a bit of glue to stick it to the top, so I have a nice curvature to it. But otherwise, nice semi-replaceable brake pad. I guess not super replaceable with the glue in there, but I don't think it would take a whole lot to get that glue to release. This model is missing all of the hardware that I used in it. I did test prints of, I did a cutaway of this section here on the brake pad holders, just to test if I could have a nice bolt and a nut in the slot here to clamp it nicely to the axle. And that worked well enough in the test piece, so I just multiplied by 3 because I wanted a bit more clamping force. on either of them. Just having the one bolt wasn't enough for what I needed, so I made 3 of those on either side, mirrored it, which is a bit of a fun process, and stuck those on. Also have 2 springs that are missing in the assembly, but they would sit in between these 2 cups underneath the pedal. And those would push the pedal back up once you stepped on it to keep it from rubbing on the tires. And here it is on top of the longboard. You can see the springs in place holding the pedal nicely up, keeping those pads off of the tires. You can also see a bit of the brake pad material in the background there on top of the cutting board that I used as a cutting surface. Now that I glue it all set, the pedal was locked in place on the dowel. It was time to go outside and test it. Once outside, our old friend the bumpy sidewalk reared his friendly face again and rendered most of the footage, well, absolutely useless. I took a screwdriver, screwed everything in as tight as I could again, even wrapped everything nicely in duct tape as you can see in the footage there, and nothing. It's just sliding down every time, shaking every time, and just looking completely terrible. Only good footage I got was on a little bit of flat section where I was riding on the brick edge instead of the sidewalk edge. And as you can see, there is one major flaw with this design, and it was, well, the pads didn't get in the way from the wheels turning, they did get in the way from the board tilting. And so as you turn the board, the board would tilt over, and the pad would run on top of the wheel and flip the whole pedal up. That was the only major failure of this design. A second minor failure of this design was that the 2 brake pad holders on either sides lacked the necessary clamping force onto the bar to lock them in place. I say this is minor because it would be easily remedied with just some glue, or creating a slightly more complicated bar and lock design where they're physically locked in place as opposed to just using friction to hold them. The second minor failure of this project was that the brake paddle wasn't quite stiff enough to hold your weight. As you can see in the video there, you'd press on the left side and the left side would go completely down while the right side would stay up because the plastic would just bend instead of hold its shape. This should be fixable by just using a stronger material than PLA or by increasing the fill level of that part. I went out for one last filming day to compare using the brake pedal to just using your feet to just going down regularly. The one in the top using the brake pedal, and as you can see, it did slow me down a bit and was actually kind of noisy, but it wasn't able to slow me down completely. And so that marks the end of version 1 of the longboard brakes. I learned a fair bit during this process and look forward to applying that knowledge to future iterations. Hope you enjoyed, and see you in the next one.